and our liver and any animal liver. Bile does something called emulsifying, which just basically means it takes fat and breaks it up into tiny, tiny, tiny droplets, increasing the surface area, making it easier for enzymes to get at it. Okay? All right, so then let's take it from there. What is this hanging off the median lobe? The gallbladder. And what does that do? It stores the bile. Okay. So how does the bile then get to the digestive organ that needs it? Through the bile duct. Okay. There's a whole bunch of vessels here, and we'll go into those a little more when we get to circulation. But the one that leads from the gallbladder is the bile duct, which I believe is this one right here. It would be the clear one. Okay. It would not have color in it. It would not be either yellow, red, or blue. It would be clear. And it would take bile from the gallbladder. And if you trace it all the way, I believe it does go all the way to the intestine. Okay, so now let's go back a little bit. The shark grabs onto a little squid and chomps it down and swallows it. Where does it go?
Esophagus.
Through the esophagus, which we didn't really look at very much. But if you look, this is actually pretty good. This is opened up pretty well. Okay, there's the esophagus. You can tell the esophagus from the inside of the stomach because you've got those little papillae in there, esophageal papillae, and I guess their only function really is to kind of ease the transference of something that's entire, right? There's not a lot of mechanical digestion happening up here. The shark doesn't have chewing teeth. It just bites and swallows, okay? So it goes down through the esophagus into what organ here? Into the stomach. Okay. So in the stomach, you have what going on? Digestion. Two kinds of digestion. Chemical and mechanical. So it's a very muscular organ. It also has these ridges in it, which are the rugae. The rugae have a couple of functions. What's the main function? Allows it to stretch, allows it to contract and stretch. Because remember, sometimes if you swallow something as big as a giant fish, it goes in your stomach, you need to have some capacity to hold it, right? So sometimes if you open these sharks up, you'll find that it's enormous and all the rugae have smoothed out, right? And sometimes you'll find that, oh no, it had ate a long time ago and the rugae have kind of gone back to their original ridges. Okay, and they also provide increased surface area for enzyme secretion, for the chemical digestion that's also happening here. Okay, so down the food goes through here, and then the next region of the stomach is called the pylorus, which is very muscular, and if you actually go down into the pylorus and trace through, you find something called the pyloric sphincter, which is basically a puckered hole through there, if I took my forceps down through there. Now this is very muscular and very tight. Why do you think it is?
To hold the
to make sure it doesn't go back up.
Okay, so well, a couple of different reasons. It makes sure that whatever is being digested in here cannot get to the intestine unless it is ground up. Right, really well ground up. So it's involved a bit in mechanical digestion, but it's also just kind of like a squeezy doorway, right? So that by the time it gets through here, it can only go through there if it really has truly become chyme, right? Chyme, which is what food becomes when it's been fully chemically digested. Okay, so the pylorus curves around here, and then it turns into something called the duodenum. The duodenum is kind of a region between the stomach and the intestine that receives a lot of enzymes and digestive juices. It receives them from a couple places. It receives them from the gallbladder we just showed you. It also receives them from this organ, which is what?
Duodenum.
No, the duodenum is here. Nope, not the spleen. Pancreas, yes. Okay, so the pancreas, the most obvious part of the pancreas is here. There's also another lobe of the pancreas under here, which is sometimes not very visible. This is not too bad. There's a dorsal lobe of the pancreas here, and there's a ventral lobe here. And both of them secrete things like insulin, glucagon, tryptophan, a bunch of other enzymes into the duodenum, along with the bile coming from the bile duct. Okay? So you've got a lot of chemical digestion happening with that chyme. Then you go down into this organ. What is this?
Small intestine.
It's the intestine. There's no small or large intestine really in the shark. And it's actually called the valvular intestine. And why is that?
Because the valves on the side.
Because if you open
The
it up,
rings.
this food hasn't really been cleared out here. If you open it up, I know it's difficult to see this, but if you look at the drawings, it's a little clearer. There is a valve in there that makes a spiral staircase, basically, right? And that is what the shark has. Instead of having a long, wormy intestine like we do, this is really, really long, they have a short intestine with a very long pathway inside it. Right? The valve causes the food to have to travel around and round and round and round and round until it gets out of the body. Okay, what's the purpose of the intestine in any animal?
Absorption.
Absorption of nutrients into where? Into the blood. And look how many blood vessels there are on the intestine. That's why they're there. So the spiral valve is an absorptive surface that gives the food nutrients a chance, a nice long chance, to be absorbed into the blood that then goes and provides energy for the mitochondria and the cells of the body, right? Okay. At the bottom of the intestine there is a colon where the solid waste collects, and then the solid waste that has not been absorbed comes out here. And if I close his fins up like this, back to where they originally were, this is called the cloaca. And it's actually Greek for sewer, if you've been reading your manual, right? The reason why it's sewer is because everything comes out there. The solid waste comes out, and also in the male, you have a urogenital papilla right there, that white thing, okay? And that white thing secretes urine as well as semen. So semen, urine, solid waste, all coming out of the cloaca, okay? All right. Going back up, I think one of the hardest things for you guys to place and identify are the blood vessels. Shall we do that?
Yeah. Yes.
Okay. Blood vessels. I always begin the story up here. Okay. So let's imagine we have all of the deoxygenated blood coming back from the body after having had the oxygen taken out of it. And it goes into something that isn't often very visible, but there are two cardinal veins on either side of the dorsal aorta that go all the way up the spine, okay? Collecting all the deoxygenated blood and taking it to, if you can imagine, a sinus, a big cardinal sinus where all the blue blood collects, okay? And it's under here. Okay, I'm not going to cut into it, but it's underneath here. It all collects right there. Not in the esophagus, but underneath it. Okay? And goes into, eventually, a sinus under the heart that you have identified called the sinus venosus. Remember, the sinus venosus is the place where the blue blood collects before it enters the heart. The first place it goes into, the first heart chamber it goes into is which one?
The right.
Atrium.
The atrium. There's only one atrium, and here it is, right here. It's big, okay? It's a very big atrium. It collects all the blue blood, and eventually that blood goes into the second chamber, which is the ventricle, this big muscular one on top. Okay. So 2 chambers in the fish, 2 chambers in any fish, and only one direction of circulation in a fish heart. And all of the blood going through the chambers of the heart is deoxygenated. There is no oxygenated blood inside the chambers of a fish heart. And it's all being pumped from the heart to where? To the gills, yes.
Wait,
but goes through the conus arteriosus first, right?
I have a question. How does the heart get oxygenated blood?
You're way ahead of me. Okay.
Always.
It's all right. No, I can always count on Hitoshi. Okay. But I hadn't forgotten. All right. So here we've got the conus arteriosus is going to go up, and it's eventually going to take the blood to these gills here to get oxygen. So there's no pulmonary circulation in a shark. Once it gets oxygen, it doesn't then go back to the heart and get circulated through the body. It just goes straight to the body after that. So one-way circulation. It's only systemic. But to answer Hitoshi's question, there is some blood in the heart that is oxygenated, and you can actually see really well. In fact, I might use this heart tomorrow. Do you see those blood vessels on the surface there that are pink? We have them too. What are they called?